Hi children, good morning. Good morning to all of you. Welcome to our St. Clair's School online classes children. Right. So regarding 8th class, almost all we completed one of the topic chemical bond and the second topic that is the solutions. Almost solutions also we came to ending. Here regarding solution we discussed a lot of points in the last classes and in the last few days back we discussed about some qualitative properties. So there are four qualitative properties are there. So here that four qualitative properties we have discussed about. First one about what is that? Elevation of relative lowering of vapor pressure. Relative lowering of vapor pressure. Here relative lowering of vapor pressure, what we are saying here, P naught minus P by P naught is equals to small w1 by capital N. So that means simply what we are saying here, n1 by n1 plus n2. Right children? So this is we discussed about the relative lowering of vapor pressure, and the second one about elevation of boiling point. Elevation of boiling point. Here elevation of boiling point we are represented as delta TB equals to KB into here m1 by small w1 into w2 by small m2. Right children? This is about elevation of boiling point. Third one, depression of freezing point. Depression of freezing point. Here depression of freezing point represented as delta T of equals to Kf into m1 by small w1 w2 by small m2. Right children? So now coming to the fourth one, that is the osmosis. What children? Osmosis. So here what is meant by osmosis? What are the points we will discuss in osmosis? We will discuss now. Right children? So the fourth qualitative property, that is osmosis, it is represented as 5. It is represented as 5. Here relative lowering of vapor is represented as a RLVT. Here elevation of boiling point represented with a delta TB. Here depression of freezing point is represented with a delta TF, and here osmosis can be represented with 5. Right children? So now we are going to discuss about what is meant by osmosis. What are the terms we are getting in the osmosis? Right? So what is meant by osmotic pressure? What are the applications of osmosis? These are all points we discuss in this particular topic. Right children? So now listen all of you carefully. So what I am writing the points on the board, you have to write in your CW. Okay children? So now coming to the fourth qualitative property, that is the osmosis. What children? That is the osmosis. See here, osmosis. Right. Here osmosis. What is meant by osmosis? What is meant by osmosis? Here osmosis, it is derived from the one of the Greek word, that is osmos. What children? Osmos. What is meant by osmos means, the meaning of osmos means, that is the to push. What children? To push. What is that? What we have to discuss here, to push. What is the meaning of to push? Right? See here, generally osmosis, it is the concept of solutions. It is the concept of solutions. Right children? In case of solutions, we are getting the two terms. What are those two terms? Solute, solvent. Both combined together we are to consider as a solution. We are to consider as a solution. When you compare the particle size of solute particles and particle size of solvent particles, here solute particle size of solute particles is more. Size of solid particles is size of solid particles is more compared to the solvent. Size of the solvent particles. Size of the solvent particle. That means when you take in the solute particle size is more than that of solvent particles. Solid particle size is more than that of solvent particles. Right, children? See here, suppose if I am taking the one of the solvent and here I am taking the solution. Suppose without touch the both of the containers, we have to mix the solvent into the solution means we require one of the membrane. So that is the membrane. The meaning of membrane means layer. What you mean? Layer. Right? So do you know that onion layer, and when we take in the egg cell, it is one of the layer. So that is the way I consider as a layer. So the layer we have considered as a membrane. So that is the membrane we had considered as a semi-permeable membrane. What you learn? Semi-permeable membrane. Okay, children. See here. So first of all, we will discuss about what is the definition of osmosis, and after that we will discuss about what is the definition of semi-permeable membrane. Okay, children. See here, what is the definition of osmosis? What is the definition of osmosis? What is the meaning of osmosis, children? To push. Right, children? So here, what is the definition of osmosis means? Here the force, the flow of solvent molecules into the solution. The flow of solvent molecules into the solution we have to consider as a osmosis. We have to consider as a osmosis. See here, the exact definition of osmosis is the exact definition of osmosis is here the spontaneous flow of here simply the simple definition, the flow of solvent molecules into the solution, but exact definition, the spontaneous flow of solvent molecules into the solution. The spontaneous flow of solvent molecules from pure solvent to the solution. Okay. The spontaneous flow of solvent molecules from pure solvent to the solution, or so the meaning of these two definitions same, right? Or here the spontaneous flow of solvent molecules from less concentration in solution to less concentrated solution to more concentrated solution, through SPM. SPM means semi-permeable membrane. Right children? So the spontaneous flow of solvent molecules from less concentrated solutions to more concentrated solution through semi-permeable membrane is called as osmosis. Is called as osmosis. Directly what we are seeing here, the flow of solvent molecules into this solution through semi-permeable membrane. Through semi-permeable membrane we have to consider as a osmosis. Right children? See here, this is the definition of osmosis. Sir, here we are getting the one of the term, that is the SPM. What is meant by SPM? What is meant by semi-permeable membrane? What is the definition of semi-permeable membrane? Right children, once again, simple what I am saying here, the spontaneous flow of solvent molecules from the pure solvent to the solution through semi-permeable membrane is called as osmosis. Actually, that means we are pushing the solvent molecules into the solution through semi-permeable membrane. That is we have to consider as a osmosis. Okay, children. So now coming to the what is the definition of semi-permeable membrane? What is the definition of semi-permeable membrane? See here. What is the definition of SPM? SPM means semi-permeable membrane. What is the definition of semi-permeable membrane? What is the definition of semi-permeable membrane? Right children? See here, the membrane which allows only solvent molecules through its holes like water. The membrane which allows to pass only solvent molecules through its holes like a water. We have to consider as a semi-permeable membrane. Right children? So what are the examples of semi-permeable membrane? See here, what are the examples of semi-permeable membrane means like pig bladder. What children? Pig bladder and onion layer and eggshell layer and parchment paper and copper iron cyanide Cu2 FeCN6. Right? So these are all examples of semi-permeable membrane and carpolucides. Right? So these are all examples of semi-permeable membrane. The membrane which allows to pass only solvent molecules through its holes like water, we have to consider as a semi-permeable membrane. So membrane means which is one of the thin layer. What's that? Thin layer. Right? So this is about what is the definition of osmosis and what is the definition of semi-permeable membrane and what are the examples of semi-permeable membrane. Right? And where we should observe this osmosis process? So where we should observe this osmosis process means generally this is the osmosis process we have to observe in our day-to-day life in so many examples. Here for example, where we should observe the osmosis process means simply when we are taking the wilted flowers. When we are taking the wilted flowers, so those wilted flowers we are keeping in one of the flowers we are taking the water. After the next day we are getting fresh flowers. Because of that water, that is solvent is entered into the petals of the flowers. So based on that, here the next day we are getting that wilted flowers like a fresh flowers because of that water is entered into the petals of flowers. That is the one of the example of osmosis, right children? And the second one, is when we are taking the pickles, mango pickle. In the mango pickle, the dry mango pieces are there. When we keep it in the pickles, when you prepare in the pickles, after so many days, then what we are getting here, the mango pieces, dry mango pieces, we are getting the soft mangoes. Because of here, what is that? Here, the mangoes, here, mangoes. So when you take in the mango pickle, then what will happen here? Striven. Here the mangoes we are getting the striven. That means when you take in that pulp, the pulp will be in that pulp. This is the water will be inserted into that particular substance. There we are getting the soft mango pieces, right children? And third one, when you take in our blood cells, we are keeping in the saline water. Then what will happen here? Our blood cells will be increases. Because of here, that water will be entered into the blood cells. Right children? So these are the daily life applications we have observed in our day-to-day life. Those are examples of osmosis. And similarly, suppose if we can take in biology we have to discuss about this point. When I take in one of the roid, that roid we are keeping in a acid. When we keep it in a acid, see here the outer layer of the egg will be removed by the acid. Then after what will happen here? These are the acid molecules are entered into the egg. Automatically egg will be swallowed. Because of this is the osmosis process. And suppose if we can take the plants, so plants will be getting the water and the edges of the tree from the roots. So through osmosis process, the water will be travel through the plant. This is also one of the example of osmosis, right children? And now coming to the what is the difference between osmosis and diffusion? See here, what are the differences between osmosis and diffusion means? Here, diffusion and osmosis. Here, what is meant by diffusion? Means here in case of diffusion, both solute and solvent particles travel from more concentrated solution to low concentrated solution. See here, that means both solute and solvent, both will be traveling from more concentrated solution to low concentrated solution. Right? Here, in case of osmosis, only solvent molecules will travel through semi-permeable membrane. Only solvent molecules travel through semi-permeable membrane from less concentrated solution to more concentrated solution. But solid particles will not travel. For the diffusion process, no need of semi-permeable membrane. But in case of osmosis, semi-permeable membrane is must. Without semi-permeable membrane, we cannot enter the solid molecules into the water. Right, children? So these are the differences between diffusion and osmosis. Then in the next class we will discuss about what is meant by osmotic pressure and what are the applications of osmosis. These are the points we will discuss in the next class. Okay children, so please all of you stay home, stay safe. Thank you.